Hello explorers and welcome to another video. Today we are doing the Advent of Code puzzle. The Git repository is linked in the description below, and if you want to see all of my trials and tribulations, you can see the full recording as a member of this channel. Day 7. No space left on device. You can hear birds chirping and raindrops hitting leaves on as the expedition proceeds. Occasionally, you can even hear louder sounds in the distance. How big do the animals get out here anyway? The device on the elves gave you has a problem with more than just its communication system. You try to run a system update. Please, pretty please, with sugar on top. No space left on the device. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the result in the terminal output, your puzzle input. For example, okay, so here we have some commands and some outputs. The file system consists of three files, plain data and directories, which can contain other directories or files. The uttermost directory is called /. You can navigate around the file system, moving into and out of directories and listing the contents of the directory you're currently in. Within the terminal output, lines that begin with $signs are command you execute, very much like a modern computer. CD means change directory. It changes directory is the current directory, but specific, the result depends on the argument x. ZDX moves to one level. It looks like the current directory for directory named X and makes it the current directory. CD dot moves out one level, which finds the directory that contains the current directory, then makes that directory the current directory. CD / switches directory to the outermost directory. /ls lists, it prints out all the files and directories immediately contained within the current directory. 1, 2, 3 ABC means that the current directory contains the file ABC, which has the size of 1, 2, 3. Dir XYZ means that the current directory contains the directory XYZ. Okay. Given the command output in the example above, you can determine that the file system looks visually like this. Okay. Here are 4 directories. / it's the outermost directory, A and D, which are in / and E, which is in A. These directories also contain files of various sizes. Since the disk is full, the first step would probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the files it contains, directly or indirectly. Directories themselves do not count as having any intrinsic size. The total sizes of directories above can be found as follows. Total size of directory E is 584 because it contains a single file, I, of 584 and no directories. The directory A have a total size of 94,853 because it contains files F, size, and G and HLSD, which has a bunch of sizes, plus a file I directly, indirectly, and AE, and which contains I. Directory D has a total size of 2 million or 24 million. As the outermost directory contains every file, its total size is 48 million. And the sum of the sizes of every file. To begin, find all the directories with the total size of at most 100,000 and then calculate the sum of their total sizes. In the example above, these directories are A and E. The sum of their total size is 95,437. As an example, this process can count files more than once. Find all directories which has a total size of at most 100,000. What is the sum of the total sizes of those directories? So let's save day 7 then. First off, and let's see how the input of day 7 looks. So it's a bunch of these slashes and so on. So that's good. And it actually does cd slash in the beginning, which means that the current working dir is slash. So that's really good that we start at the root for both inputs. So now I think we need to create some classes, directory, and then we have file. Or we can do file entry and directory entry, like that. And file entry extends directory entry. No, we do the other way around. So we have a file and directory entry that extends file entry. So file has a size. Public file entry. Like that. And it also has a name. So the size starts at 0. We don't need that actually. We can have final string name and final size, string name, and then name is equal to name and size is equal to size. We do like that first. So now we have that, and then we want to create this constructor with no size, and this should be 0. Okay, we can only do getters, of course, because we're setting it as a final, so we can't set it. So that's reasonable. So now we have a directory structure, and then we can have and a directory entry can have a list of files. So list file entry containing files. New array list. Like that. Files. and then add public void add file, and then we have file entry. Files add files and fee. Haven't figured out that one yet. Let's put in list like that, and then public int get size. This is for file entry fe in files if fe is an instance of a directory entry, then we will see count. Can have a long here. Count start at 0. So we will take count and add the size of this directory entry. Like that. And the size of that. Otherwise, we take fe and get size and add count to that. And we could also just change this getter to just be called size like that, because then actually just need to run get size and then return count. Because then it doesn't really matter what type it is. All of them have a size. The directories just don't have any size of their own. So that's interesting. So now we just need to parse the input. We have a bunch of ls, we have a bunch of cds, and then we have the dir command. So I think we will do as we usually do. Line array. And we split it by space here. And if the first is a $, equals line array 0. So here we will handle command. And if this is dir, then we will create a new dir entry. Current directory. And then we have a directory entry, which is root directory. Like that. So this is just called slash. We also need this parent. like that. Because we need to go up one. So we need to have a parent there. Okay, like that. So now, here we can say that this is null, so there is no parent directory. So if we have a directory, then we will take current directory. And new directory entry with current directory as the and then we will have line array 1. So that is what we want to do there. What's the problem here? Might not have been initialized. So at the moment this is the root directory. So there we fix the directory part. If let's see here, it's numeric, or we can do else. So hopefully there will be no other weird parts. So else we will take the current directory and add a file, new file entry, where we have the name of the file, which is the second part, and then the first part, long, parse long. And then we will change this file entry from having a small size to a larger size. So hopefully that will fix our problem there. So now we just need to handle all the different commands that could be here. I think I will ignore all the ls. Just ignore them. So if line array 1, if that is equal to cd, then we will do something with line 2. So line 2 could be 3 different things. If line 2 equals slash, then current directory is equal to root directory. Easy enough. Then we will have an else if it's 2 dots. Then current directory will be current directory get parent. Get parent. So we jump up one. And else we want to go into that directory. So current directory equal to okay, so this is not what we want to do. We will want to add a file here as well. But it's just a directory entry. Current directory is current directory get dir, and then the second part here. And get dir, if we create that in this, we will have files. Let's make this easier and have a map here. Hash map. Like that. Values. String file entry. And this should be collection of file entry. So that is easier. And here we will, instead of add, we will put, and we will take fe get name as the part there. And here we will go through the values, count the size, and here we will take files, get the specific string, and return that file. As a directory entry. Could be incorrect, but let's do that. We will have a list of directory entry, and this will be all directories. New array list of all directories. Like that. And when we add a directory, we will add that and directory entry to our all list as well. So we have two pointers, or two ways of getting all those. So for directory entry in all directories, if then we do an int count here, if de size is less than 100,000, then we will take the count and add the de size. And we can do a little bit of an optimization here to have a long size. Will probably not make that much of a difference, but it's better to do like that. And then we can print count down here instead. So now we should have the right value. We do. And if we then change over to our full set here, we hopefully can find the right value for all the directories. So that's a larger value. Let's put that in here. Yeah, you get a gold star. I get a gold star. Everybody gets a gold star. So the first part is solved. Now you're ready to choose a directory to delete. The total disk space available on the system is 70 megabyte. 70 megabyte. To run the update, you need unused space of at least 30 megabytes. You need to find a directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost directory, and thus the total amount of the used space, is that, which means that the size of the unused space must currently be that, which isn't quite 300,000 required by the update. Therefore, the update still requires a directory with total size of at least 8 megabyte to be deleted before it can run. To achieve this, you have the following options: delete E, delete A, delete D, or delete /. Directories E and A are both too small. Deleting them would not free up enough space. However, directories D and / are both big enough. Between these two, the smallest is D, increasing used space by 24 megabytes. Find the smallest directory. If deleted, would free up enough space on the file system to run the update. What's the total size of that directory? So first off, we need the full space, and we need to subtract that with that value. If we remove that, we can do like this. So the first we want to do is take the root directory and get the size of that. Long size of roots. So that's the root directory. And then we want to take space left minus the size of root. And then we want space required, space to remove is equal to that much, 30 megabytes. So that is how much we need to remove. So now we can do the same as we did before. List directory entry candidates. It's a new array list. So now we have a list of candidates that we can remove. So if the size of this directory is larger than space to remove, then we will add it to the candidates. Easy enough. So if we go down here, we should have 2 directories now that is in the candidates list. Currently we only have 1. And that's because we are not counting /. And I wonder if that is fine to not count /, because it doesn't really matter for us. Hopefully we don't need to remove all of it. So we can take this candidates list, just for funsies, we take the candidates and add the root directory, just so we have 2 of them. Like that. So now we should have 2 directories. And then we want to sort them using an AB function and B minus A. I see A and B as directory entries, of course. What's the problem here? Cast to int. Okay. Let's do that. Should probably be fine. Because the values can't really be that large at this point. So we have 2 candidates, and the root is the first one. So that's the opposite of what we want. We want the smallest on top. So now I should be able to take candidates, get 0 size. And that should yield the smallest one, that is the one we want to delete. So if we now do the same with our long list, we should get that directory. So that's the smallest one we can delete. Okay, let's try that. Yeah, you get a gold star, I get a gold star, everybody gets a gold star. So we have solved day 7 as well. So what did we do in the last one here? Well, we still had our parsing up here where we parse the directory information and create our 3, and we have all the directories that we can use down here. Then we have some calculation up here to figure out how much we need to remove. We create a list of candidates that we could remove. We go through the list and see which one are actually candidates. And then we will sort those candidates. We get the smallest one on top. We add the root directory for completeness because it's not in our starting list here. And then we will just print out the first entry because we know that is the smallest one. So this is what day 7 gave to us today. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you have any comments or suggestions or some code that I could look at, please leave it down in the comment section down below. I love to see other people's solutions to these problems. If you haven't subscribed yet, please do that, and I really hope to see you in the next video.